All right, derivative of a constant function. Okay, constant function is a type of line. It's a constant. What kind of line? It's just a horizontal. So here's my example. You see where it has d dx of 3? Think of this as y equals 3. If I were to graph this, what's the slope of that line? 0. So the derivative of any constant is going to be 0. So if I said d dx of 1 million, it's still just going to be 0. If I said d dx of square root of 2, 0. d dx of 0, 0. There you go. Okay, so that's easy. That one was an easy one. Now we'll get into the power rule, and this is the one that's going to save us time. And you're going to be like, why didn't you teach?
Yeah, it's n-1.
Why didn't you teach me that before? It would have made my life so much easier. Well, we still need to understand all those limits. The rule is when we have x to a power, we're going to move that power to the front, and we're going to subtract 1 from the exponent. So if I have x to the 5th, so
5x.
5 moves to the front.
That's so fancy.
Subtract 1, 5x to the 4th.
What?
Okay.
There was no water. The vending machine is completely broken.
Yeah, the ice.
This is a travesty.
Do you have water?
I don't have water.
I do.
A travesty.
Okay. So that there are do they not have water fountains?
They do. They have
They're
water
blocked
bottle.
off, I think. No, they're only water bottles. Here's the one with herpes, actually.
Whoa.
Whoa.
Okay,
Whoa.
keep in mind I'm recording.
Of course.
Of course. Let's continue. Constant multiple.
Olivia's skills. Okay, I want it now.
All right, here we go. If we have a constant multiple, meaning a coefficient, we can move that coefficient to the front. Now, this is a situation I probably would jump right to the answer, but I'll show you. You can move that 4 to the front, and then just do the derivative of x squared, and then multiply the 2 together. So, according to our power rule, this would become 2x to the first power. So I would have 4 times 2x, which would be 8x. Now, looking back at the original problem, couldn't I just still do that with the 4 in front? Yeah. This is like extra work that I normally wouldn't show, but just so you can see. Later on when we get to more difficult derivatives and later on integrals, sometimes it's easier just to forget the coefficient and deal with that later. Okay.
So this is so much easier.
Well, we only got started, okay? Sum and difference. So this just means you can distribute through to each part of like a polynomial, for example. Again, I wrote out the steps here. Normally we wouldn't write each detail, but you think about it as doing d dx of 4, which would be, what's the derivative of a constant?
0.
0. And then I would do d dx of 5x cubed.
15x squared.
Good, 15x squared.
So 15x.
Yeah, so just 15x squared. So when we're doing the derivative of something like this, we'll just take the derivative of this, derivative of this, derivative of this, and then combine. Good? Okay, any questions? Those were the first few major rules. Okay, take a look. So it says find dy dx, meaning find the derivative. You can write, I don't really care, you can write dy dx or you can write y prime. It's the same thing. So I can write dy dx or y prime. Okay, we can do this, right?
Mm-hmm.
All right, what's the first term going to become?
12x cubed.
12x cubed. Second term,
18x squared.
18x squared. Yeah.
If you're separating them, like, do you have to write dy dx in front of it every time, or you just like?
Next one.
1 over x over 4.
x,
It's 2x.
Oh, it's 2.
right? Because the 2 would go in front, so that would become 2x to the first power over
And then
2.
Minus 0 plus 0. Aren't you doing it to the root? To the power
Okay.
of 0?
Think of, if it's x over 3, we're going to think of this as a minus 1/3 x.
So it's just gonna be
So minus 1.
Wouldn't it be-
Okay.
you have to bring it
Oh, yeah, because you're.
across.
Right, if I just thought of this as like a negative, if I just look at the last part here, there, think of this last part as the equation of a line. What's the slope of that line? Negative 1/3. The slope of the 10 is 0.
But don't you have to bring the, like,
Yeah, but
when
you-
there's a constant and a variable, I thought you had to multiply or bring the variable. But you didn't do that.
Well, we could,
It would,
so,
it would basically be negative 1/3 times 1 because anything to the 0 power is
Yeah.
1.
so it would be negative 1 x to the 0 power over 3, but
Which is
anything
that
to the
1/3,
0
yeah.
power is
No,
just,
but I thought you have to put the, like, multiply the x over 3 by 3.
There's no exponent here.
oh, this part.
Yeah.
Yeah, but this technically is an x to the 0 power. Anytime you have a constant, it's a degree of 0. We don't need to worry about that. Okay, next one. Same thing. You want to give
What
it
about the
yourself?
plus 10?
What's the derivative of a constant? Just becomes 0.
Okay.
Now, in example B, we have a constant this time, but it's the first one. There's really
So it's
no
just
work to do for these.
0?
It's just 0. So if I say y prime, here, give this one a try, and I'll. Did you get it?
It's got like that.
Did
That's just
you
not
figure out this one?
Oh, yeah, I got that.
Oh, okay.
sure.
Oh, yeah, I already have that written down.
Oh, all right. Tell me what you got.
Oh, you want me to like solve it out? Yeah. Okay, I can do that. I can do that for you.
Okay, please do.
Okay, you got it wrong. You got it.
I didn't get it wrong.
Okay,
No,
anyone
I wanna hear his
else?
answer now.
I would love to.
River?
Cool.
I got negative 6x to the 5th power plus 1/2 x cubed plus 7.
Yeah,
Oh,
so
I
it's
did
wrong.
forgot the over 2 here.
0
I forgot.
minus 6x5 plus 1/2 x
Why is the x all the way down there? It was like 1 over 2x.
plus
Okay.
7.
Yeah.
I did such a good job, Miss Casey. Adam is just a
Can we just
sturdy
keep it at this
liar.
level?
Big capper.
This isn't.
This isn't bad. This is
No,
like
no,
that.
that's why I'm asking. Like, this is easy.
Yeah,
This
it's
is
it's plus 7 because this
Is
is just to the
first, yeah. Okay, next. We want to find the horizontal tangents. Horizontal tangents are when the slope is equal to 0. Okay, in this case, we have dy dx when that is equal to 0. Okay, so go ahead and first find dy dx. Now, if we're setting this,
Oh, I know how to do this one.
Do you, Jack?
Yeah, I do.
and whatnot. So 4x cubed minus 4x.
Yep.
We want to set this equal to 0. So let's go ahead and set it equal to 0. And in the meantime, we're going to factor the right side. So this gives us 3 different places where we have horizontal tangents.
0, 1, negative 1.
Okay. All agree?
Yeah.
Now, this is where the tangents occur. What would be the actual tangent since it says find the horizontal tangents?
Y equals.
Y equals. So what do I need to, I'm gonna plug back into the original.
Oh wait, can we use like y prime instead of writing dy over dx? Same thing, right?
That is the same. So we're gonna plug x back into the original. So if I plug in 0, that's
2.
just gonna be y equals 2. And what happens if I plug in 1?
1.
1 minus 2
Plus.
plus 2, so 1.
If I plug 1 in here?
Oh,
1
are we
minus
plugging-
2 plus 2?
We're plugging all of them in?
Yeah, and
All 3? Okay.
yeah, and what happens when I try to plug -1 in? It's the same thing. So this is a situation where if you look at the original, it's like an x to the 4th. So it looks like a kind of that W shape. So if you imagine like here and here, that would be the same tangent. And then that's essentially what kind of shape we have. So it's okay that when you plug it back in, you get the same answer for these.
Okay.
Okay.
I like this way better. I thought you guys should know.
All right, we have 2, other than the power rule. The power rule is the big one from this lesson. We also have the product rule and the quotient rule. I'll put stars next to these because these you do have to memorize. Okay. So when we take the derivative, and I'm going to highlight the one on the right because it's a little easier to follow. So if we have 2 things multiplied together, we're going to do the derivative of the first, keep the second one the same, plus then we leave the second one the same and do the first one the same and derivative of the second. Okay, now,
That's where u times v in pre-calc comes from, like vector.
oh, like vectors? Not exactly, because that will apply more to Calc BC when we do vectors in BC.
You can be our BC teacher.
I have no idea who's teaching next year. Okay, so let's say this is U and this is V. So what would U prime be? And what would V prime be?
2 and 3.
2 and 3? Okay, so I'm going to do the derivative. So it's U prime V. So U prime is 2 times 3x minus 5. Always plus. And then U times V prime. And it doesn't matter which one we put first. I actually like to put the coefficient first. Because the derivative of 2x plus 1 is 2. Right? Think of both of these are y equals mx plus b. What's the slope of this? 2. What's the slope of this? 3. We okay with that?
Yeah, I'm good.
Okay, multiply it out.
It's 12x minus 7.
It is 12x minus 7.
I'm ahead of the game.
Now, just a note. We could have actually done FOIL and then done the power rule, but there will be times where you have something like 3x times sine x. You can't like distribute that, so you have to do the product rule. Okay. This is our second big one, or I should say third. So we have power rule, product rule, and now quotient rule. So this one is here. So we're going to do the denominator times the derivative of the numerator minus the numerator times derivative of the denominator over the denominator squared. Not as simple as the last formula, right? No. Okay, so we have a little way to remember this. It sounds a little silly, but I promise you if you can remember it, it helps. Okay, so it goes low D high. So I'll say it first. You'll say it, don't worry. Low D high, take high D low, cross the line and square the low. Okay. Low D high, take high D low, cross the line and square the low. So where does this, if you can just remember that low D high part, because low D high, take high D low, cross the line and square the low. So let's see where that helps us with the formula. Okay, what's low represent? The denominator. What's D high? Derivative of the numerator. Take, that's our subtraction, high D low. So numerator times derivative of denominator.
Yes.
Cross the line and square the low. Okay,
It's a very fancy song.
you like that?
I like it a lot.
So yay, low D high, take high D low, cross the line and square the low. If you want to memorize the formula, go right ahead.
I can do that.
I'll
It's
be-
all the
I'll be-
same.
I'll be singing the song during the test.
Don't sing the song during the test.
So sine, cosine, cosine.
Yeah, not the
I will
sine,
do that during
cosine.
the test.
Okay, so low, what's on the bottom? X minus 1. D high,
That says X minus.
sorry, X minus 4.
She wrote it.
I wrote it, I just said the wrong
You're all
thing.
good.
Okay, so low is X minus
Yeah.
4. D high, what's the derivative of the top?
2.
2.
Oh,
Take, now we do high D low, so
1 times
2x.
minus 1 times 2x.
and the derivative of the bottom is just 1. Cross the line
X minus
and square the low. Don't bother multiplying out the x minus 4 squared. Just simplify the numerator. So that'll give us what? 2x minus 8. The 2x's cancel, so we just get negative 8. Okay. In a problem like this, there's no way we could have found the derivative using the power rule. So sometimes, even though the last one with the product rule, we could have multiplied it out, there's no way for us to simplify it. So we had to use quotient rule. Okay, let's try this one. So low.
Should we try canceling out or no?
No, don't cancel anything out.
Okay. Low D high.
Low D high, take high D low, cross the line and square the low.
So fancy.
yep.
Let's see. All right, I'll freeze mine. You guys are working on it, so. Yes, we do have to multiply it out.
Did you multiply at the bottom?
No, no, no. When you get to the end, you can look to see if the numerator will factor, but does it?
We're doing this the same.
Does it factor?
What do you mean D
It does not.
high?
Derivative at the top. D high means derivative of the top.
So the a derivative is like the instantaneous point at a.
The instantaneous slope. The
Yeah.
slope of the tangent line. at that
Sloping at the tangent at a particular point. Now, we're not finding it at a particular point. We're saying take this rational function and what's the equation for the tangent at any point?
Integral is like the shaded part under the graph, right?
Wait.
Yeah, it's a little bit more than that, but yes.
We learned that in physics.
What?
Did we not get that?
No.
I got
Uh-oh.
that.
Oh, I got that.
I got that.
Oh no, what
Wow, you
happened?
guys make me feel really good about myself.
Yeah.
Let me
It
see.
was just, I got
Free.
slope for this one.
Oh, it's, you forgot to do the derivative at the top here.
Oh, wait, derivative is 100.
Yeah.
Oh, because it's plus 4. Hey, why'd you add the 2x plus 4 and not just the
How did I
Well,
get
what's the
this
derivative of the top?
high?
2x plus 4.
Oh wait, the high. You're not. Oh, the second time you're not supposed to take the derivative. The song's confusing in this case.
Oh, I did get
Okay, then just use the
So
formula.
all it
So
is.
just memorize.
Can't we just leave them like that?
I got really close to that, but I did it in the complete wrong way. I got really close. Like really extra. Like, if there
Yeah,
was
big
no
time.
4, I have minus 4x.
Is anything like x minus 1 or like x plus 8, x minus 4, is that just 1 for the derivative?
What do you mean? What?
Like, Find the derivative
That's
of
not
x
the bottom.
minus 1. Is that always just going to be like 1?
Actually, I listened to that song in the
Like, it
morning.
doesn't matter what it is if x minus 8.
Oh, yeah. Yeah.
Before it's unlocked, yeah.
Okay. The next page, we're almost done, and then we actually might have, the other class we got like halfway through the homework. So, power rule for negative integers is actually the exact same as positive integers, okay? So if I have 3x to the negative 4, we're going to do the same thing. So it's going to be negative 12x to the negative 5.
Do you want us to
So,
write it out with like the 1 over?
so anytime I ask for it in simplified form, we would want to get rid of negative exponents.
Oh, so you increase the exponents.
I mean, yeah, because like if you think about negative 4, if I take 1 away from negative 4, negative 4 minus 1 would be negative 5. Okay, find an equation for the line tangent to the curve. So what do I need in order to write the tangent line? I need a point and I need a slope. So if I know x is equal to negative 2, I can find out the slope pretty easily by just plugging it in here. So that'll be 1 over negative 8 or negative 1/8. So now what we want to do is we want to figure out what f prime of negative 2 is going to be. So first thing I would do, think of this 1 over x cubed as x to the negative 3. Now technically you could do quotient rule. I would not, right? It's if you can just rewrite it with a negative exponent, it's so much faster. So when I do f prime, negative 3x to the negative 4.
Negative 4.
I got that.
Okay,
Got that.
bless you. So it's going to be negative 3 over x to the 4th. So now over here, I'll have negative 3 over negative 2 to the 4th. So that'll give us,
I'm confused where you got the
Negative
f
3
of
over
negative 2
negative 8, so
from.
3/8. Wait, no, 3/16.
Can you publish his notes online?
Yeah, where'd you get like the negative 1/8? Does that have anything to do with it?
that's what, it says at the given point. So my x is at negative 2.
Okay.
So then I found out the y coordinate, so I have a point.
From where?
1 over x cubed.
Oh.
I always need, listen, I need a point and I need a slope. So I need to have the function.
Point slope, right?
Yeah, so I can just leave it as y plus 1/8 equals negative 3/16 times x plus 2. Good. Okay, so now we have,
Never mind.
we have a different function. There's actually 2 ways I can do the derivative. We can actually simplify each of these terms and then do the power rule, or we could do quotient rule. Why don't I do quotient rule just for some extra practice? So dy dx. Okay, so take the denominator, 2x, times derivative in the numerator, low d high. What's the derivative at the top?
2x.
2x, there we go. Take high d low, so we're going to leave the x squared plus 3 times derivative of the bottom, 2. Cross the line, square the low. Now, oh, I forgot we didn't find a point, but you can plug it in. What's that? Let's do that real quickly. What's y? What's y of 1? There's just going to be
4 over 2.
Which is
So 2.
2.
That's 2, yeah.
Okay.
I was about to say, I was on the verge.
Now, I want to find
Guys,
y prime of 1, or dy dx evaluated when x equals 1. I'm not going to bother multiplying this all out with x. If I know x is equal to 1, it's so much easier just to plug in the 1 from the beginning. Right? Do I really want to distribute, find like terms? No, just plug in 1. That's going to be 2 times 2 minus plug in 1 here, so that's just going to be 4 times 2.
Yeah.
All over. So that's going to be 4 squared. Or no, sorry, that is 2 squared. 2 squared. I didn't leave a lot of room here. So this will be 4 minus 8, so negative 4 over 4, which is negative 1. Okay. Much easier. If you know the value that you're plugging in, do not make more work for yourself and multiply that all out. Okay, so my equation of my tangent will be y minus 2 equals negative 1, x minus 1. Good.
Wait, how is 4 minus 8 negative 1?
No, because it's also over 4, because it's 2 squared. So this will give us negative 4 over positive 4. Okay, last thing, this is second and higher order derivatives. So all that we've been doing so far is first derivatives. There are second derivative, third derivative, fourth derivative, and we can continue on. The ones that will actually have application generally only go up to the fourth derivative. Let's just look at the notation. So if it just has 1 mark, that's dy dx, that's the first derivative. If it has 2 marks, that's the second derivative.
What does that mean on the second?
It's the derivative of the derivative.
Okay,
So
okay.
think of something when we apply it to our physics, if you will. Like your original function is your position function. Your first derivative is your velocity, right? It's the change. And then your second derivative is acceleration. That's the change in velocity, okay? Third derivative is the change in acceleration, also known as jerk. And then beyond that in physics, we don't really apply, but fourth derivative we'll use when we have sine and cosine repeating. Okay,
Yeah, wait, I never heard of jerk.
you have it?
What is jerk exactly?
It's what causes motion sickness.
Oh, you mean torque?
So anybody who has,
Sorry, isn't it almost torque?
so if you get motion sickness, right, some people when they can't see or are seasick, right, they have to see like the horizon. Why? Because you don't know when the unexpected change in acceleration. So the jerk is what causes your motion sickness. Oh.
So it's the third derivative of velocity.
Wait, so,
Their derivative of position.
so even if they don't
Not
know why
displacement.
they're looking
Displacement
at
is
that
different.
horizon, it's
Okay.
an unconscious thing to look at the horizon and move the
Third
finger.
derivative, we'll get used to the notation. For right now, you can just use the basic one on the left. Anything beyond the third derivative, we put the number in parentheses. Make sure you include parentheses because we don't want to think of it as an exponent, okay? Good. So we're going to find the first 4 derivatives of this function. Okay, so starting with the first one, which is what we've been doing, we're just using the power rule. We get 3x squared minus 10x. Okay, so now we kind of ignore that starting point. Now we're going to continue. So our second derivative,
6x minus.
yeah, we're just going to base it off of this. So that'll be 6x minus 10. Third derivative,
Six.
just 6.
And the fourth is 0.
Yeah, so 4 we're going to put in parentheses. Technically, you could put these in parentheses too. We just usually reserve that for.
Could
Should I
you
put
put
4
4
dashes?
dashes?
No.
No.
Okay.
And it
Good.
has to be, and it has to be parentheses, so you know it's the derivative.
Right, otherwise it